Hello, Applied 30S students. So today we're going to talk about graphing to solve linear inequalities. So you should be on page 22 in your booklet. So the boundaries of a solution of inequalities may or may not be included depending on which inequality signs the system contains. You can validate the possible solution from the solution by checking that it satisfies each inequality in the system. Substitute the coordinates of the solution into the inequality and determine whether the inequality is true for these coordinates. Use an open dot to show that an intersection point of a system's boundaries excluded from the solution set. An intersection point is excluded when a dashed line intersects either a dashed or solid line. Use a solid dot to show that an intersection point of the system boundaries is included in the solution set. This occurs when both boundary lines are solid. So if you have two solid boundary lines, you're going to be doing a solid dot. If you have a dashed line, use a open dot, and if you have a solid or dashed line, use an open dot. So we're going to graph the solution for the following system of inequalities, and we're going to state two possible solutions. So we're going to validate our set, in other words. So we have 2x plus y is greater than 6, and then we have y is less than 3, less than or equal to 3. So let's start this off. So first we need to find 2 points for each so we can put it onto our graph. So what I did was I made in my first one x0 and I solved for y, which I found to be 6. So my first coordinate point is 0 and 6. My second coordinate point I made y to be 0, which made x3. So my second coordinate point is 3 and 0. So since y is less than or equal to 3, then I can just make my y equal to 3. So my new coordinate points for that one is 0 and 3. So now I'm going to graph my points, and I'm going to use two different colors. Remember, my first point, the 2x plus y is greater than 6, is going to be a dashed line. My less than or equal to is going to be a straight line, a solid. So my shaded portion is where the two lines intersect, and that portion is my solution set. I went below and not above the green line because my answer is less than or equal to 3. So therefore I have to go below the line. So let's validate to see if my solution set is valid or not. So to validate the graph, what I want to do is I want to pick 2 points that are in the solution set. So if I go back, let's find 2 points that are in the solution set. So I picked 3 and 2 and 4 and 1 because they lie in my shaded area. So now I'm going to set up a t-graph that says left side, right side. And what I'm going to start with is I'm going to start with my first equation. So my x is 3 and my 2 is y. So since 8 is greater than 6, this point on the graph is valid for that line. And I checked my other line, and it was y is less than or equal to 3, and since my y is 2, I validate that one as well. So let's try another point to see if it's still valid. So both of my points are valid. So this solution set we can say is valid. So we checked it by setting up t-charts for left side and right side and finding points that correspond in our shaded area. So now, am I going to have where my two lines intersect an open dot or a closed dot? I am going to have an open dot because it is a solid line and a dashed line that intersect. Okay, so turn to page 23 and let's do a practice problem number 1. So it says for each system of linear inequalities, determine the point of intersection of the boundaries. And then will the point be solid or open dot on the graph system? Explain. Okay, so let's start with A. So I found my points. So x minus y is less than 2. So my x-coordinate are 0 and 2, and my second coordinate is minus 2 and 0. Then in the x plus y is greater or equal to 0, I have the coordinate 0, 0, or 4 and negative 4. So the next thing that I want to do is I want to graph it. So as we can see by the graph, I have an intersecting point. At the point negative 1 and 1. So is that going to be an open or closed dot? It is going to be an open dot due to the fact that it is a solid line with a dashed line. So next what I want to do is I want to prove to you why we're going to use a dotted or a open dot. So the reason we do an open dot for this one is because the intersecting point will not lie within the solution set or the shaded area, because we used negative 1 and 1 where the intersecting point was. And if we use our validation t-chart, x minus y is supposed to be less than 2 when we found out it is 2, but we don't have a less than or equal to sign, so therefore it's an open dot because it does not lie within our zone. So now we're going to go on to part 2 of it, since we determined the point of intersection, and it will be an open dot, and we explained why. So next thing, since we graphed it in question number 2, now we're going to determine its validity. So we're going to pick a point within the shaded area. So I picked the points negative 1 and 0 and negative 3 and negative 2. So let's see if it fits. There we go. So let's do that again. Let's pick two new points. Alright, so 2 and 1 and 4 and 2. Sorry, I shaded the wrong part. So I proved that those ones are valid in our shaded area. So what I want you to do for your assignment, I want you to finish off on page 23, do the second point, so do number B. And then I want you to do page 24 to 25. And that's it.